Hello everyone, welcome back to another video of our Data Science Basic to Advanced series. In this video, we will be learning about logistic regression. Let us first know what logistic regression is. So, the logistic regression is used when the dependent variable is binary, that is 0, 1 or true false. It is commonly used for classification tasks. Logistic regression is a statistical method which is used for binary classification tasks where the dependent variable, also known as the response or target variable, is categorical and typically with two possible outcomes. The outcome can be success, failure, 1, 0, yes or no. Despite its name, logistic regression is a classification algorithm and not a regression algorithm. Let us understand logical regression by taking an example code. Understand logistic regression through this example in which we are importing some of the necessary libraries like pandas, logistic regression, and confusion matrix and accuracy score. We're giving it an example data set and then splitting the data into predictors and target, that is in the value of x and y. And then we are splitting the data into train and test. Then we are creating a logistic regression model and then training the data and then displaying the confusion matrix. So here we get the output of the confusion matrix which says the value is 0, 0, 1 and 0. So the assumption of logistic regressions include while logistic regression is a powerful tool, it relies on several assumptions. First is linearity in the logic. That means the relationship between the independent variable and the log odds of the dependent variable should be linear. No multicollinearity should exist, and observations should be independent of each other, no autocorrelation. Large sample size. Logistic regression requires a sufficiently large sample size for reliable estimation, especially when there are many predictors. Let us understand some of the applications of logistic regression. Logistic regression is widely used in various fields for binary classification tasks such as medical field, finance, marketing, and social science. Logistic regression is a fundamental algorithm for binary classification by modeling the probability of an outcome based on the logistic function and estimating model parameters using maximum likelihood estimation. In understanding and predicting binary outcomes, it is an interpretable and widely used in various domains, making it a valuable tool for many practical problems. Now, we have another type of regression, that is Poisson regression. Poisson regression is used for modeling count data where the independent variable follows a Poisson distribution, that is the number of occurrences of an event. Let us understand Poisson distribution through an example code. We are importing some necessary libraries like pandas and states model API. We are giving the data set, example data set to this model, and then we are defining independent variable that are predictors and then adding constant to the predictors. Then we are defining independent variables, that is the value of y, and fit the Poisson regression model using generalized linear model. Let us run this code. This output, the coefficient interpretation, the coefficient of the predictors 1, 0.5821 indicates that a 1 unit increase in predictor 1 leads to an expected increase in the log of outcomes variables count by 0.5821, holding other predictors constant. Also, the p-values for both predictors are above the typical significance level of 0.05, meaning that there is not enough evidence to reject the null hypothesis that the coefficients are equal to 0. This suggests that predictor 1 and predictor 2 might not be significant predictors of the outcome. Further refinement or additional predictions could be needed to improve the model. This was all for logistic regression. I hope you understood the topic. Thank you for watching.